Okay, people seem to have stopped arriving in the chat channel, so I guess I'll start. So I wanted to talk today about some problems that we've been having with the Xen Project CI system. So to give some background, the Xen Project, we have our own CI system which gates updates from the developers from staging to master, and that mostly runs. So there's two CI systems. I'm talking about osstest, which is the one which runs bare metal tests of Xen on a variety of different x86 and ARM hardware. We've got a test lab in Massachusetts with 2 racks worth of, well, about 2 racks worth of equipment, several dozen machines of all different kinds. We have lots of different machines to produce lots of exciting different bugs. So unfortunately, we have a bit of a problem. Many of the code bases we're using have bugs which have which are probabilistic, so they don't turn up every time, and we don't get a test push if there are any regressions. And a regression is like a test failure that we didn't have in the baseline, which is whatever current master is. These low probability, well, you can have quite low probability failures which then come through and they get into the tree. And the reason for this is that when I wrote the system a long time ago, the Heisenbugs were a bit less common, and the approach I took was just to detect when a Heisenbug was occurring and to call that a pass. So the logic is that if you run the tests on the same version and you've got at least one pass, that will count as a success. This is not ideal, but because Heisenbugs are by their nature probabilistic and they tend not to show up with very high probability, it's difficult to keep them out of the tree completely. But the approach I've taken doesn't work very well with the current large test suite we have, which has about 100 tests in a normal test run, and the number of Heisenbugs we have at the moment, which is unfortunately rarely 0. And the result here, we see, here's an example of the reports, 2 reports from the system, where we can see that this test failed, this XSM Debian HVM. So that's a HVM test involving QEMU, and the test failed. And then it reran the next run on the same version. The test passed, and then it called that a success. And it had to have 2 or 3 attempts, depending how you count them, at that. And this is quite wasteful resources, and it also gets in the way of development. So I have some plans to do something about this. So the first plan I have is relatively straightforward, which is to kind of mitigate this won't improve the code quality of the tree, but it will mitigate the resource wastage and the slow, the fact that we don't get code pushes to master. So I'm intending to retest only the failing tests immediately. That should be relatively quick because there won't be very many of them, and I'll give it a high priority. And that ought to mean that most of the time we'll get a push first time round, or at least after the selective retest. And this will waste less of our machine time. It will give us a push in a more timely fashion, but it will still tolerate Heisenbugs. So there still won't be trying to do anything to reduce the proportion, the number of these bugs and their probability in the code we're testing. So I have a more comprehensive plan that I'm going to present here for the first time as a set of suggestions, and I don't know exactly what people will think of this, but and suggestions are very welcome. But my basic idea is, firstly, to try to characterize Heisenbugs, particularly to try to determine whether some particular probabilistic failure occurred in the last stable Xen release, which more or less means we've, if it was in the last stable Xen release, then we've already accepted that as a bug. And if not, then we could report it as a confirmed regression, and hopefully the release manager and the developers will pay attention to that. I don't know, we haven't had always people taking test failures as seriously as maybe they ought to, but I'm hoping that a confirmed Heisenbug regression would be useful information that people would act on. So in order to do that, and to have good confidence in the answer, and that's essential because people start to disregard reports that they that aren't reliable. So I've done some sums. So I should explain what some of these figures are. So we're essentially doing a statistical test here, and there are two important characteristics for a statistical test. One is the power, which is how good it is at finding a real difference or a real effect. And in this context, that means how good it is at not, at spotting when something actually is a regressing Heisenbug. And then we've got significance, which is the probability, well, not the probability, but somehow the likelihood that a report of a difference, in this case, a report of a regression, is it corresponds to a real regression. So if you look at these numbers in the table there, I've assumed that we want to be highly confident that when osstest reports that something actually is a regression, it does so, and that we also want to avoid getting any significant numbers of regressions in. And I made some sort of example scenarios there for the probability of the failure in the baseline. So any test is not, unfortunately, always 100% reliable. In practice, they do seem to be very reliable. I think the 1 in 10,000 figures there are probably closer to reality than the 1 in 1,000 figures. Heisenbugs, of course, vary a great deal. The worst ones are about, 1 in 20. We have had ones that show up only occasionally, and 100, that show up maybe one flight in 10 out of a flight of 100 test jobs. And that corresponds to the 1 in 1,000 fail probability there. Something like that is basically really impossible to be, if it comes up so rarely, then in order to be sure that it was really a regression, you need a very large number of tests. According to my calculations, there are about 50,000 test runs, which would give you, if it has a failure probability of about 1 in 1,000, that would give you about 5,000 failures. 50 failures. And that would be enough to be confident that that was a real effect. In practice, I don't think we have the resources to do that. a 1 in 200 failure probability that happens like once every other flight. Could be, even if it only affects one particular host. Sometimes we have bugs that are host specific. You could track that down in 6 months, and that seems like a long time, but you're using basically one machine, taking one machine out to just like automatically track down this rare bug. If the failure is more common, then you could find it in a couple of weeks or so. So I think this is plausible. It won't find the bugs. I mean, that is, it won't find the cause. It won't identify a particular commit, but it will be able to be sure that something actually is a real effect. And also, it will be able to characterize, once you've noticed that something is a regression that was in the baseline, you can maybe do something to the tests. There's one other thing that people often say to me in this context. I'll go back a couple of slides. It's often people, developers who read reports like this and notice that there are many of these sort of stochastic failures, think the problem is, oh, the tests are just unreliable. And I'm pretty sure that's not the case. If there are, actual problems that keep coming up, I'm pretty sure they're actually bugs in the software under test. Sometimes a host-specific bug might be a BIOS bug, but most of the tests that are failing occasionally in our actual tree don't seem to be host-specific. I'm pretty sure they're real bugs. We also have the osstest does some careful self-tests of its own network performance and so forth. So, I have a standard of 0 packet loss, for example, on the test network. And I don't think these are infrastructure problems. I think they're just, bugs. So I'm not sure how valuable this is. There's a certain amount of work here to implement this. I think it would be reasonably doable. The next possible thing I might do is automatic bisection. Now, I haven't yet done the complicated algebra for how many tests you'd have to do to finally track down a Heisenbug that was introduced since the last release. A lot of that will depend on how many commits there have been since the last release when it was introduced. It's going to be probably hundreds or thousands. So you might very well find yourself doing, 10 or 20 bisection steps. Naively, you could use the same single test as before that we were using to determine whether something is an aggression. And so you could probably multiply those numbers on the right by a factor of 10 that way. But I think it's probably possible to do better than that. But in any case, it's not going to be very fast. So even the best kind of Heisenbug is probably going to take months to track down this way. And the benefit of this is really that it will take very little human effort once the system is working. As I say, there's some algebra to be done here to understand exactly how probabilistic bisection has to work. We wouldn't want to do this for all trees. In particular, the Linux tree doesn't bisect very well because it has a lot of merges in, and that means that normally the baseline that the history graph is so complicated that the bisector has a tendency to blame merge commits, and that doesn't really tell you anything interesting. But it could probably find things in Xen reasonably easily. Okay, so that's the second part of my part 2 plan. as I say, these numbers on the right are for testing a single revision, and you need to multiply those up. So the implications of this, obviously there's a certain amount of development time. The probabilistic bisector is a non-trivial amount of work. I think the automatic characterizer is probably not very hard. But so there's some development work, mostly of me, but also there's some resource usage. So for a bug affecting many or most of the hosts in the system, if you introduce such a Heisenbug, it will probably take about half of osstest resources for a matter of days or weeks to confirm that that was indeed a Heisenbug. Of course, if the bug is fixed in the meantime, then that work can be abandoned. But if people are ignoring it, then it seems to me that that's a good use of resources to confirm that this is actually a real bug. If it's a host-specific bug, then it uses much fewer resources, obviously, because it can only test it on those particular hosts. And it will use a lot of those hosts to hunt the bug down. I'm kind of hoping that deploying something like this that is at least giving developers a confirmation that they have introduced a Heisenbug and that it is a regression, might concentrate minds and might improve the code quality. So hopefully osstest won't be doing this all of the time. I'm not sure whether I'm being over optimistic. The alternative to that is just to do the first part of the plan, which is the auto retest, which will free up a lot of resources. That'll get us faster pushes. I think it's a no-brainer to do at least this, but the question is whether we want to do better than that. Okay, so that's the resource usage considerations. So there are some difficulties with this proposal. The obvious one is bugs that can't be confirmed or somehow aren't bisectable. Mostly these fall into three categories. There's situations where something not under the test system's direct control changed. The most obvious one of those is, unfortunately, we need to occasionally update to new guest operating systems. We use, in many cases, we have tests that test unmodified guest operating systems. And when we update those, sometimes they turn out to have bugs. And, well, we could not update until somebody had fixed that guest, but in practice, that doesn't seem to be very practical. This is especially a problem for Debian guests because we use those for a lot of our tests. And if a Heisenbug slips into the Debian stable kernel, then that can cause us trouble. I think that the example we had earlier was one of those. Another kind of thing that it will have difficulty with is bugs that are in the baseline already. So if we release with a Heisenbug, either because it's been there since before we put the system in, or because we just got kind of unlucky and it slipped in, as in the CI didn't spot it, then this approach won't really help, because if you can't find a baseline that's working, at least a reasonably recent baseline, then automatic tests are not going to help you very much, and you'll have to resort to possibly debugging it or something. And the final thing that will be really difficult for it to deal with is any kind of thing with a low probability, because as I said earlier, if the Heisenbug has a very low probability, well, to get confidence, you need a large number of occurrences of the bug, roughly speaking, 1 over your chance of false positively claiming that something is a Heisenbug. So if you want to be confident, then that you don't make more than 1 in 100 false reports of Heisenbugs. You need to, roughly speaking, each Heisenbug that you declare to be, you actually declare and report, has to have turned up 100 times ish in your tests. And if it has a very low probability, that can take ages. The other difficulty I can see why this might not be a good idea is it's not worth spending a lot of effort producing test output if nobody is going to be paying attention to it anyway. Particularly the Heisenbug regressions, the Heisenbugs reported by osstest are often not investigated by the code experts in that field. The Linux kernel, particularly stable Linux kernels, seem to occasionally acquire quite serious regressions, which then sit around for weeks or months even before somebody maybe fixes them. Another difficulty that this system might encounter is if there are large commit ranges where the build is broken or basic functionality is broken. We had one of those recently, just before the 4.14, just after the 4.14 freeze, and that makes bisection difficult. We sort of vaguely plan to do some of the CI before we push to an on-rewinding branch. That is, if the tests fail, you'll be able to rewrite your branch so that it passes, rather than sort of patching stuff on the end on master, and that will help with that. Other reasons for being skeptical about this plan are, well, osstest does whole system tests on bare metal hardware. These are very expensive. You have to wipe the machine, physical machine, you have to wait for it to boot. The tests are all mostly, well, not all, but mostly integration tests. And they use a great deal of resources for testing. They're not very intensive at testing particular pieces of functionality. We definitely need a lot more XTF tests that do exciting things. And XTF is already integrated into osstest, but we need to expand that a lot. And also, testing in general is not a substitute for good code quality. It can help, but it basically just divides your bug rate by a constant factor. And if another really good way to get better code quality is just to have better code. But my proposal does at least mean that if the bug isn't fixed, the release manager will probably know, and much of the time it might pinpoint a particular commit that's responsible. Okay, so there's a question for the community here. Is it worth pursuing this Heisenbug confirmation plan, which has significant development effort and significant resource usage? Is it worth pursuing Heisenbug bisection? Again, that's more development effort and more resource usage. The automatic selective retest is a no-brainer. I'm going to do that anyway. And also have a plea for the developer community. We've got far too many of these bad bugs. We've got far too many complex races. And I think a lot of that is due to our development style. We make too little use of semi-formal methods, often internal, even in basic internal data model and API invariants are not written down anywhere. Some of our coding styles are invitations to human error. And we make too little use of more modern ways of programming that are more intrinsically safe. So my baseline here is that routine human error should not result in awful Heisenbugs that are impossible to track down or security advisories. We should try to arrange that mistakes by programmers, straightforward individual mistakes by programmers, are either avoided or caught somehow. So that's my plea. If you have opinions about this, I mean, you can, I think we're on to questions now. So if anybody wants to have any questions in the chat, we've got a few minutes. Or you can catch me on IRC or maybe in the hallway track with your opinions, or you can send comments to I'll post a summary of this to Xen Devel, or at least a link to the slides, and you can reply to that with your opinions. Thank you. See some people typing. XDF. So XDF is a unit test framework done by Andrew Cooper. So it has these. It's a system for building these tiny little mini VMs that exercise particular pieces of normally hypervisor functionality, or compare hypervisor behavior to real CPU behavior, or check that XSA bugs have been properly fixed. Maybe Andrew can produce a link to that. So they're unit tests. They can be run. They're in they're in their own Git tree, which you can find on XenBits, and they can be run separately, and they're also run within osstest. I think Citrix certainly use them within Citrix's proprietary product test system, and I think other people may be using them separately too. Preferred approaches. Yes. Well, at the very basics, I would like to see a lot of the code in Xen is very, at the very least, I think that complicated data structures and state machines ought to have a formal description in a comment of what the invariants are and any peculiarities. Some of the code that we've seen responsible for advisory recently is frankly almost impossible to follow, and you can spend a whole afternoon digging through it and drawing diagrams on whiteboards. So that should not be necessary. It should be possible to see what the invariants are written down and compare them with the code and check that it's correct. And I think if we did that, we'd probably discover a lot more of these bugs. Ultimately, we could use formal verification systems. And as for safer languages, well, I've recently been getting into Rust. I'm not saying we should rewrite the whole hypervisor in Rust. That's probably not practical. It'd be full of unsafe code anyway. So, but for routine stuff, maybe we should be considering not writing things in C, because it's a bit of a liability when we can avoid it. So yeah, thanks. That was a good question. I see one more potential question, but I'm not really thinking of something like Misra. By its nature, Misra isn't very well. It has a focus on simpler systems than Xen is, and there's a lot of irreducible complexity in Xen. That means that Misra itself is difficult to apply. I know people are trying, but that's awkward. I was just thinking about conventions to do with variable naming, conventions to do with initialization approaches, conventions on error handling particularly. There are ways of structuring your code, and this is a thing that we need to do pervasively in when we seem to spend a lot of our time as hypervisor developers arguing about coding style questions, and I'm not sure that the focus on preventing human error is quite as much at the forefront of that as it should be. I'm thinking more in terms of like the coding style document. Okay, well, thank you, everybody. Thanks for listening. I think it's the break time now. It's 1:15. If you want to keep chatting about this, I guess I'll hang around in this room for a few minutes longer if anybody has any more questions. Okay, it looks like we're probably done here then. Thank you. Have a nice rest of your conference. Oh, hello. Um, how much of my time am I spending on this test stuff? More than half. I'd be very interested if anybody else wants to help out with the OSS test. You can find me on list or on IRC. It's not what I want to be spending all my time on. Is there any opportunity, Rich? Yes. Is there any opportunity to work with other hypervisors on Heisenbug testing? I'm not sure how much bare metal testing the other hypervisors are doing. I'm not aware of, um, like KVM, for example, having a system similar to OSS test with a lot of bare metal testing. The problem of testing Heisenbugs itself is not obviously a new one. I have done a bit of a look round to see if anybody has written code that I could reuse. It doesn't seem so. So I think I'm going to have to roll my own, and I'll try to make that a thing that's reusable. I think it would be nice to have a thing that you could run out of git bisect, or a thing that was like git bisect but worked for Heisenbugs. And most of the complicated algebra will be applicable to that case as well as to the more complicated OSS case. Cool, thanks. Okay, thank you. Take care all.